plus C1 is equal to 0. This is first circle. I have two circles now. See here. My second circle is S dash. I am not taking it as S1 because we used S1 for some other notation, tangent equation, all those things we used S1. So S dash is x square plus y square plus 2g2x plus 2f2y plus c2 is equal to 0. Look at this, I have taken two circles. Now when I take two circles, what are the possibilities? What are the chances? These two circles may be like this, or one circle may be inside the other, or one circle may be just touching, or one circle is cutting the other circle, and one circle touching the other circle externally. This is touching internally. One circle is inside, not intersecting, like this various cases. That is 1, 2, 3, 4, 5 possibilities. But how do we know the 5 possibilities? How are the circles positioned? We don't have any idea. So we have a brief this thing. Let me explain you all the 5 positions how to decide. Then we will see our questions. On common tangents, let me give you a small this thing. We have two circles. Well, there we have this is the position. First circle center is, I call the first circle center as A minus G1 minus F1. And second circle center is minus G2 minus F2. And first circle radius is, I will take it as G1 square plus F1 square minus C1. Second circle radius is G2 square plus F2 square minus C2. Did you understand? So the case 1, and I'll take all the 5 cases. Please, if you note down, you will understand what is the position of the circles. First of all, let us see how they are. First circle center, second circle center. Let AB be the distance between the centers. Distance between the centers. I'll make a easy approach for this, how the circles are positioned. You have taken all these things. Now look at this small figure. I just draw like this. It is easy way to remember. Your R1 minus R2 is here. Your R1 plus R2 is here. This is sum of the radii and difference of the radii. Now here I will call it as AB. Suppose if AB is here, easy way to remember, please see, if AB is here, one circle will be inside the other circle. That means if AB is here, one circle will be inside the other circle. How do we write like this? If AB is less than R1 minus R2, one circle is inside the other. This is called relative position of two circles. Important also. Relative position of two circles. Very important. Look at this. 5 cases. All the 5 cases let us explore first. Then once you understand the concepts, we can do the second set of 7 questions. If AB is exactly equal to R1 minus R2, circles touch internally. Circles touch internally. I will put it here like this on the arrow. Here the situation is like this. One circle is inside this. In case your AB is in between these two, that is, if R1 minus R2 less than AB less than R1 plus R2, that means AB is here. A very important thing. Circles intersect. Circles intersect. Circles intersect. And if AB is exactly equal to R1 plus R2, AB is equal to R1 plus R2, circles touch externally. Circles touch externally. Let us look at this. And if AB is finally more than R1 plus R2, circles will be like this. They are non-intersecting circles. One circle will be like this, one circle will be like this. Here circles, one circle will intersect the other circle. Here if you take one circle will touch externally the other circle. All the 5 positions depending on R1 minus R2 and R1 plus R2 are described. You once again look at them. I will explain. If AB is less than R1 minus R2, one circle is inside the other circle. If AB is exactly equal to, here R1 minus R2 means in some books they use the modulus. The reason is we don't have the idea which is big, either R1 or R2, which is big, we don't have the idea. So we keep a modulus. If AB is exactly equal to, in an IPE questions, some of the questions they ask you, show the circles are touching internally. That means you have to show distance between centers is difference of the radii. And now let us see the common tangents. If AB is between R1 minus R2 and R1 plus R2, the circles will intersect each other. And if AB is equal to R1 plus R2, exactly, the circles touch externally. This is the position. And once AB is greater than R1 plus R2, circles, one circle will be outside the other circle. Now let me see how many tangents you can draw. Here there is no common tangent, you know very well. Here the common tangent is simply one tangent. Here you have two common tangents. Here you have one here, two here, three. Here you have four tangents. These are direct tangents. These are transverse. The tangents which are crossing each other are called transverse. Or simply, if one circle is this side, one circle is that side for a tangent, it is called a transverse tangent. Here, if you take this tangent, I will just like a quiz, let us see. This is a very important point. If you take circles like this is one tangent. This is called transverse tangent because one circle is that side, one circle is this side. This is called transverse tangent. Okay. Now we have the 5 positions. But what is important in exam? In exam, they give you 2 circles. Okay. After giving 2 circles, they ask you, show that they are touching, intersecting, or touching internally, touching externally, like that. That is first part. Then once they are touching, find the equation of common tangent. How do you find the equation of common tangent? This is the topic now. How do you find the equation of common tangent? See, when the circles are touching internally or externally, the common tangent is S minus S dash is 0, this one. But what about the other tangents? These tangents are important. How do we find them? For that, we will find, I'll just tell you of an important case. Now my heading is common tangents. Relative position of 2 circles we have already seen in the last lecture. Now we will see what is common tangents. When 2 circles are given like this, suppose, these are called direct common tangents and these are called transverse common tangents. Okay. This is called S1, this is called S2. What are S1 and S2? S1 and S2 are points of similitude. Points of similitude. This is the thing. S1 and S2 are points of similitude. Now, this is my first center A. This is my second center AB. This is R1. This is R2. How do you get S1 and S2? How do you get S1 and S2? If you divide the line joining centers AB in the ratio to get S1 and S2, to make it a note, it's a very important thing to get S1 and S2. I always keep this in mind. To get S1 and S2, just divide the line of centers, in the ratio R1 is to R2, internally once, externally once, internally once and externally once. If you do that, you get both S1 and S2. Once you have S1 and S2, I will tell you how to find the equation of tangent. First, this is what the lecture is. Let me tell you 2 circles relative position we have seen, and our aim is, sometimes our 7 marks question is common tangents. So common tangents, how to find the common tangents? First of all, you have to find the location of the circles, the relative position of the circles. Once you have the relative position of the circles, then we can decide how to get the common tangent. KAB E-classes, our motto is to put you in the right track. You can sit at home and get all the lessons. We are giving you lesson by lesson. Total IPE syllabus will be covered and will be presented to you by different experienced lecturers.